Hi everyone, in this video we're going to solve a normalization exercise and we're going to start with this one, health history report. Basically when you look at this table, this is the unnormalized form. If you want to see the definition for unnormalized form, you can check the slides for the course. So if you look at this table, it actually looks like some form that was filled out and it was handed to the database manager, engineer, whoever deals with the database, and now it needs to be put in the database. And since it's unnormalized form, you can say because these, for example, this pet ID 246, this dog and age and the owner, this is the same dog and the owner that went to these visit dates and got these procedures. So there's actually, if you put it as is, there are null values, but null is not allowed. And to convert this to first normal form, we have to deal with two things. First, we need to make sure every row has values and each data cell has only one value. For example, if you look at the procedure, right, let's go here, if you look at the procedure values, these have basically two values in one data cell, right? So 01 is obviously some kind of procedure number or procedure ID, and then rabies vaccination is the name of the procedure. So we have to break that up. We can do the same for the owner, right? The owner is Sam Cook, but he has a first name, he has a last name, but they're both put in one data cell. So I'm going to break that up to convert to first normal form. But first thing first, we have to make sure there are no null values in the beginning. So, and since these are the repeating values, this is the same dog and same owner that went to visit dates on March 20, January 13, March 27, April 2nd. I'm going to flatten the table. So this is what the flattening table is. Right, so I have flattened this table so far. And then the same thing needs to happen here for Terry Kim and his dog. Put it here. So Terry Kim visited his dog on January 21st, March 10th. And then we have Sam Cook with his cat. He went there again. And Terry Kim also has a bird. So these people have more than one pet. That's one thing you can tell from looking at these database. Okay. Now the table is flattened, but I still have a problem with data that is stuffed into data cells. You know, data that's supposed to be represented by two columns, such as with the procedure and the owner. What I'm going to do is I'm going to break up those data. For example, I'm going to create a new column, and I'm going to put all the procedure IDs into that column. There's a unique procedure ID for each procedure. If you look at 01, it's rabies vaccination. See, it holds for every row. 10 is examine and treat wound, and then you get 05, heartworm test. 20 is annual checkup. 12 is eyelash. So mostly in these exercises, we're going to work based on the information that is provided by the form. So you can tell by looking at procedure ID, there's one unique procedure ID for each procedure. And visitation date is fine. So we're also going to break up the owner. It makes more sense because right now the owner, you know, with the way it is, you cannot search the owner by name or by last name. I'm going to give each owner an ID because, you know, people may have the same name. You may have two people with the same name. For this case, I'm going to create another field here. That's going to be owner ID. So this is the first normal form. Okay. First normal form for this database. First normal form. And that's pretty much it for the first normal form. Each data cell has one atomic value. It doesn't store more than one data, and there are no null values. The table is flattened. Now we can work our way to second normal form. In order to find second normal form, we have to determine partial dependencies, and to be able to determine partial dependencies, we have to determine each functional dependency and candidate key. Now, what is the rule for functional dependencies? For example, if A and B are attributes of a relation R, B is functionally dependent on A if each value of A in R is associated with exactly one value of B. For each value of A, there's only one value of B. So let's look at pet ID and see if we can determine pet name from pet ID, or another way to say it, does pet name functionally depend on pet ID? Now let's see, for 246 Rover, 246 Rover, same name, 246 Rover. Now we can look at the different dogs. For 298, it's just Spot. There is no another 298 value, and there's a different value for 298. And then let's look at 241 Morris, 241 Morris, and then 519 Tweety, 519 Tweety. So you can say that all these names depend on the pet ID. So we can say that by looking at this table, pet name depends on pet ID. The same goes for the dogs. Dogs depend on 246, and then not all the dogs, but this pet type, because for each value of pet ID, which are 246, 298, 349, 341, 519, there is one associated value of pet type. So for 246, there's only dogs. 298, there's only dogs. 341, there's only cats. And 519, there's only birds. There's no another animal that is associated with 519 or 341, 298, 246. Is the age the same way? Yep, you can look at it. The ages for the dogs depend on their pet IDs, right? And then you can tell from here, these ages depend on the 246, because there's no another value that is associated with 246. Same goes for the owner. 246 associated with owner 01, and 241 associated with owner 01, 298 associated with owner 02. Here's the thing, the reverse is not true though, because if you look at the owner ID, let's look at 001, you have 246, and for this 01, you have 341. Therefore, you cannot say that pet ID functionally depends on owner ID. The reverse is true. Owner ID does depend on the pet ID, but the pet ID does not depend on the owner ID, because for each value of owner ID, there is a different associated value of pet ID. So you cannot determine pet ID from owner ID, but you can determine owner ID from the pet ID. Same goes for owner name, owner last name. If you have the pet ID, you can determine these values. For 246, it's only Sam. 341 is Sam. 298 is just Terry's. 519 Terry. You can tell actually there's two owners in total in this table, and they own several pets. What about visit dates? Each pet visits the clinic at a certain date, and they may get different procedures. But just by looking at the visit date, you can't tell much, because this pet has visited 3 times. This pet has visited twice. This pet has visited twice. This pet visited once, but he got 2 different procedures. Is there a relation between visit date and the pets? Not really, but there's a relation between the procedure with their visits. But you cannot just say pet you cannot just combine pet ID and visit date to get the procedure name, which procedure they received, because the reason for that is, if you look at the Tweety here, 519, Tweety visited the clinic twice and it got different procedures. So if your key was pet ID and visit date, that wouldn't work because procedure name does not depend on the visit date and the pet ID combined. Because for the values here, 519 and 519 combined with April 30th, you have a different procedure here and a different procedure here. Therefore, there cannot be a functional dependency, right? Therefore, you also have to have procedure ID involved to get the procedure, right? So if you combine pet ID, visit date, and procedure ID, then you can get the procedure name. Now let's write down all our functional dependencies based on looking at this table. First of all, we have pet ID is a determinant for pet name, pet type, pet age, and then you can determine owner ID, owner name, owner last name. And then we have pretty much owner, first name, owner, last name. So owner ID gives us each owner, first name, owner, last name. The visit date, it only determines itself unless you combine it with other attributes. We have procedure ID gives us procedure, and then the other way is also true. Procedure can give procedure ID, and then combining that with visit doesn't do much. Then we have pet ID combined with visit date combined with procedure ID can give us all these three in the procedure. This one is not necessarily right here for now. So let's try to come up with a key. One key. So obviously the key is going to involve pet ID for sure. Pet ID. And then I'm trying to get to all the attributes. I need to include visit date in the key because there's no other way you can get the visit date. You can get visit date from visit date itself. And then if we combine these two, we also need the procedure ID. At least procedure ID, so we get the procedure. And this way I can get pretty much all the attributes. I can determine all the attributes. Pet type, pet age, pet, actually not pet, owner ID, owner first name, owner last name, visit date, and then procedure ID, and then procedure. Now let's look at the partial dependencies here. First of all, we have pet name, pet, oh, I forgot one thing, pet ID. Okay, so we have pet ID, and that determines a good portion of our attributes. Pet type, age, owner ID, first name, last name. Right, and then we have visit date, which determines the visit date. And then we have procedure ID, which determines the procedure and the procedure ID and the procedure itself. Procedure name, sorry. And this creates a problem because if you look at this portion of the table determines this attribute, this portion of the table depends on this attribute, this portion of the table depends on just this part, and the procedure ID and the procedure day depend on the PID, procedure ID, right? So this violates second normal form because this creates partial dependency. You would actually want that in a table where you have a table where you have some keys on this side and they determine everything else, right? And you will want to see if you do this color exercise we did here, you would have one color here, and then this would lead to a block of colors. Right now, this is not good. Therefore, I'm going to have to break this table down. So I may have several different tables. First one is going to be a pet table. I'm going to go with a pet table. So pet ID. Actually, let's write this pet. So this is the pet table. And through this pet table is going to have attributes of pet ID. It's basically going to store information about the pet name, and then it's going to have pet age, owner ID, owner first name, owner last name. Okay, and this is my pet table. Now I am going to, but I still have other attributes here that I need to use because I cannot ignore that data over there. And in the pet table, by the way, one thing before we skip, pet ID is the key, and it determines the rest of the stuff, the rest of the attributes. Now, what other we have? We covered pet ID, pet name, type, age, owner ID, first name, last name. Now we have visit date left, procedure ID, and the procedure left. So obviously, procedure depends on procedure ID. Okay, then we have a procedure table here. Procedure table where the procedure ID and procedure, you can name it procedure name if you want to change the name of the attribute so you don't get confused. That's fine. Procedure ID depends on procedure. And then the key for this one would be procedure ID. Procedure ID would determine the procedure name. Now we have another one left. I'm going to create another table to keep track of which days these pets visited the doctor, right? So we have pet visit table, and this is going to have pet ID, which day it visited, and then procedure ID, and then visit date. So this way we can look at it and see which days they visited and which procedures they received. Now, looking at this, for each pet and each visit date, so we need a different key. So each of these are actually going to be a key to get the unique rows. Now this, let's see if there's any partial dependencies in this case. All the pet name, pet age, owner ID, first name, last name depends on pet ID. Procedure depends on procedure ID. And each visit must be a unique visit because the date, unless you combine the date, the pet ID, and the procedure ID, you don't get a unique row. Why? Because if you look at it here, Tweety, right, 519, they visited on the same date, and it visited the same date, and it got different procedures. So in order to get a unique row, each unique visit, you have to combine the procedure ID. So if you actually want to get a unique what they received, you have to combine pet ID, visit date, and the procedure ID. And this way you can get another table pet visit. And this will actually fit the second normal form. Now we need to find the third normal form. And to do that, we need to look into transitive dependencies, determine transitive dependencies, and get rid of them. So the rule for the transitive dependency says that where you have three attributes in relation A, B, C, where B depends on A and C depends on B, and C transitively depend on A via B, and given that A is not functionally dependent on B or C, what can we now we need to find the values. We need to find transitive dependency. Okay, let's go back. So to look for a third normal form, we see that we have if you look at the pet table and our functional dependencies, the owner name if you look at our functional dependencies, the owner ID determines owner first name and owner last name. Yes, this all can be determined by the pet ID, but we have a situation here where owner last name or an owner first name depends on owner ID, and then the owner ID depends on the pet ID. This creates a transitive dependency. In order to get rid of this, we need to create another table and break things down further. So let's write our third normal form. So we're going to break down the pet table into two different tables. Pet table is going to have pet ID, pet name, pet age, and owner ID as a foreign key. Okay. And then another table, owner, where we actually store owner specific information. Owner ID, owner name, owner last name. And then the rest will be the same. Procedure table will have procedure ID, procedure name, and pet visit is going to have pet ID, procedure ID, and then visit date. And let's mark the keys for each of these. Pet ID is the primary key here, but owner ID is the foreign key, which maps each pet to their owners. Owner ID here is the primary key. You can, by owner ID, you can get owner name or last name. And then pet ID, so procedure ID determines the procedure name. And then here, for each unique visitations, you need to get pet ID, procedure ID, and visit date, where actually the pet ID and the procedure ID are foreign keys.